here we go then. Question 8. So, prove that 1 plus cos to the 4x minus sine to the 4x is equivalent to, that's just what that equal sign means. Just means it's equivalent to. Right, with these you've got to pick a side to start on. There really isn't much to do that side. I'm going to start with that side. So, never write what you're trying to prove to start with. Now, I hope that you are joining me in your absolute excitement at seeing a difference of two squares. I mean, I cannot imagine quite how happy you are at the sight of a squaredy thing minus a squaredy thing, because you know that it's the examiner's favourite thing in the world. You know it's going to come up, and it has. Here it is. Cos to the 4 minus sine to the 4. Cos squared plus sine squared times cos squared minus sine squared. Right, and now your heart is probably fluttering slightly because you've seen a cos squared plus sine squared, which you know is 1. So this is actually just that. Right, now you are probably looking at what you want. So it says that we want 2 cos squared x. So we don't want any sine squareds in our answer. Now, we've used the only fact that we know. So I would suggest that we're going to have to use this again. And in fact, look, if we're trying to get rid of this sine squared, then let's replace it with what we know it equals. So I know that sine squared from here equals 1 minus cos squared. So let's replace this sine squared with 1 minus cos squared. Now notice I've been really careful. I've bracketed this. I'm minusing sine squared, hence I'm minusing all of this. So I get 1 plus cos squared minus 1 minus cos squared. So the 1's go, which gives me 2 cos squared x as required. Now, you'll notice that the only thing I used during this was cos squared plus sine squared equals 1. If in doubt, that's a pretty good place to start. You've used the same identity twice, and you've got 4 marks for doing it. Sounds like a pretty good deal to me. Right, let's have a look at question 9. What's going on? Relative to a fixed origin, A has position vector 6i minus 3j, and B has position vector 4i plus 2j. Find the magnitude of the vector AB and the angle it makes with the unit vector I. Right, now these are position vectors, which means that they're relative to some random origin. So I'm going to just put them on. I'm going to label 2 random points, and I'm going to just put them on a picture. Doesn't matter in the slightest where you put them. And this is 6i minus 3j. Right, so that's how I get from the origin to B, and that's how I get from the origin to A. Right, what do I want? I want the magnitude of AB. Right, well, how am I going to get from A to B? I'm going to go along here, which is a minus A, and then I'm going to go along here, which is a plus B. If I call them A and B, then I can write down what I'm doing. So to get from A to B, I'm going to go along here, but the wrong way, which means it's a minus A, and then I'm going to go along here, which is the right way, so it's a plus B. Right, what's minus A? Well, it's minus 6i minus 3j, and then I'm adding my B, which is 4i plus 2j. So what have I got? Minus 6i, I've got minus 6i plus 3j plus 4i plus 2j. So I've got minus 2i plus 5j, maybe? That sounds reasonable. And it wants the magnitude of that vector. Remember, the magnitude of AB is what is kind of the length of that vector. So if you imagine that vector, you're going 2 across and 5 down. that's complete rubbish. You're going 2 across that way, and then you're going 5 up. Sorry, that was complete garbage. Yeah? I went 2 across, minus 2i, and then I went 5 up. Yeah? And I and j are perpendicular. So when we're getting the magnitude, we're Pythagorasing to try and work out this length here. So, is minus 2 squared plus 5 squared, which is 4, plus 25, which is 29. Hence, the length of AB is the square root of 29. Now, don't be alarmed when that turns out to be a nasty surd, and I would just leave it as a surd. I would just leave it like that. Right, is that it? No, we want the angle that it makes with unit vector I. Right, a picture is called for. Right, what was AB? AB was minus 2i plus 5j. Right, that's my AB, and I want the angle that makes with I. So this is, well, let's draw a picture. So I've got my I here. So what is this vector? It's minus 2 along, and it's 5 up. Okay? Now I want the angle that this vector here makes with this line here. In other words, I want that angle there. This is my I vector. This is the vector that I'm dealing with here. I want the angle that this vector makes with this line. So I'm looking at that angle. In reality, I'm going to find that angle there first, and then I know I can take it away from 180. So, SOHCAHTOA, I've got opposite and adjacent. So tan theta equals opposite over adjacent. So theta equals, again, we're going to be in degrees for this. So theta equals 68.19. So my angle here, let's call it x. So x is going to be 180 minus whatever I just got. Again, I'm going to use the answer button on the calculator, which gives me 111.8. And it doesn't tell us. We normally do 3 significant figures. So I'll give 112 to 3 significant figures. We tend to work with 3 significant figures if it doesn't tell us otherwise. So 3 significant figures, there we go. That wouldn't have been doable in my opinion without a picture. So I went minus 2i, so minus 2, and then I went up. And I just fixed an origin, and I said this is my I vector. And then so I is like the x-axis, if you like, and I want the angle that it was making with that. So that was question 9. Let's turn over and have a look at question 10. And I'm going to treat myself to a new piece of paper. So, question 10. We've got a triangular lawn. The exam writers are getting desperate. We've got a triangular lawn, and we want to find an angle, and then we want to find the cost of seeding the lawn. So I argue that it isn't actually a lawn yet. But anyway, draw a picture and label it. So I've got A, B, C. AB is 7.5, BC is 10.6, and AC is 12.7. Right. Okay. What do we want? We want the angle BAC. So that's the angle that I'm interested in. So I would label this triangle in terms of the cosine rule. So we're going to be using a squared equals b squared plus c squared minus 2bc cos a. They have, in fact, been nice in that this a and this a are the same thing. That is very, very rarely the case. I'm going to label my little letters. So my little a is opposite my big A, my little b and my little c. Right, now I'm going to stick the numbers into the cosine rule. So a squared equals b squared plus c squared minus 2bc cos A. So 10.6 squared is 112.36 equals 161.29 plus 56.25 minus 190.5 cos A. Do not add up those numbers and take away that number. Please pay some respect to BIDMAS. Yeah, this is multiplying this. Okay, so let's rearrange it. 112.36 minus 161.29 minus 56.25 equals minus 190.5 cos A. Then I'm going to divide by the 190, whatever it is, over minus 190.5 equals cos A. Right, 112.36 minus 161.29 minus 56.25 over minus 190.5. So I get that 0.552 is cos A. So inverse cos that, and we get that 56.5 is cos A. Super. That sounds reasonable. Grass seedlings cost £1.25 per square metre. So we need the area of the lawn. And we know the area is half AB sine C. So now our labelling is wrong. Now our labelling is very much wrong. So I've got a 56.5, a 7.5 and a 12.7. You probably want to label this in terms of these letters. So for half AB sine C, you've got half AB and then the angle between them is your C. So that's my C, they're my A and B. Okay, so I get half times 7.5 times 12.7 times sine of 56.5. Again, use your answer function on the calculator. So it looks like that. You can't read it. So it looks like that. Okay? And that gives me 39.7, which is the area of the lawn, and it's £1.25 per square metre. So I need to do 39.7 times £1.25, and again I'm using the answer function. Am I using the answer function? Or am I going to say that I need 40? What am I going to do? What am I going to do? Oh, I'm not sure. And I think I've got the wrong answer anyway, hilariously. No, £49.63. £49.63. Just do your answer, times that, and it's £49.63. It's fine. What a moment. That's when I needed you to shout at me. Right, £49.63 is the price of seeding this triangular lawn. So I did that number, times it by £1.25. I think in the mark scheme they would allow you to say that we would need 40 metres and then do 40 times that. They would allow that also, because that shows that you've kind of read and understood the question in context as opposed to just dealing with the numbers. They do tend to be quite good at allowing you to do it in different ways. Even though there is a right and a wrong answer, they don't always penalise you if you don't get exactly the same as them. Right, question 11. This looks like it's going to be a sketchy question to me. Sketch the curve showing whether it meets or cuts the coordinate axes. They've given you a massive clue there, haven't they, by saying meets or cuts. Very good. Right, some axes are called for. I've got a decision to make. it's going to be an x to the power 4 graph. So it's either going to look like that or it's going to look like that. I need to decide whether it's this or this by looking at what the coefficient of x to the 4 is going to be. It's going to be positive. And then the important numbers are -1, 2, and 7. Now 2 is really important because it's a repeated root. That's where the meeting comes into play. It's a repeated root, so it's just going to touch at 2. Okay? So it's going to be something like this, and it's going to touch at 2. So I'm going to come down, I'm going to go up and touch at 2, and then I'm going to go down, and then I'm going to go up through 7. Something like that. Now the reason I've gone down further is the gap between -1 and 2 is less than the gap between 2 and 7, so it's going to droop down. Now it wouldn't matter too much what you did there. They would be looking for the shape. I mean, that's a bit of a disaster. That should be smooth, but I did resist the temptation to feather. I need to know where it crosses the y-axis. To do that, I'm going to stick in x equals 0, and that's going to tell me where it crosses the y-axis. So when I put 0 in here, I get -2 squared, which is 4. 4 times 1 is 4, times -7 gives me -28. So that is what my sketch would look like. Right, a write down question. Write down the roots of the equation g of x plus 3 equals 0. Right, now think. This is a write down. We shouldn't need to do anything. What does this picture look like? Well, this was g of x, and this was his picture. Now, in x plus 3, we know that that's going to move it sideways, and we know that if the number is in the bracket, it goes the opposite way to what we would expect. So a plus 3 is going to pick this graph up, and it's going to move it that way by 3. So the roots, -1 is going to move along, and it's going to be at -4. 2 is going to move along and is going to be at -1, and 7 is going to move along and is going to be at 4. So they're going to be the 3 roots of that new equation, simply because this means pick up the graph and move it 3 to the left. Okay, this is a translation question, so I'm moving the whole graph 3 that way. Okay, that's all you needed to do for that. Don't spend very long on a write down question. Okay, there'll be a way of doing it, and your time will be better spent on other questions which aren't 1 mark. For example, question 12, which is 9 to the 2x equals 27 to the x squared minus 5. Lovely question. Right, we need to write these base numbers as the same, otherwise we can't do anything with this question. So I'm going to write the base numbers as 3. So I'm going to say that that is 3 squared, and I'm going to say that that is 3 cubed. Now, recall your laws of indices. A power to a power means that you multiply. Okay, so a power to a power means that you multiply. Now, because you've got an understanding of logs, you'll understand that if I log both sides, I'll have a 3 with a power in a log, and the power will come out the front. And I'll have a 3 to a power on this side. In fact, rather than waffling, I could just write it. Like that. So, we know from our log rules that I can bring the powers out the front like that. And now log 3 is just a number. So I can cancel this log 3 from both sides. So I get that. Now you might go straight from this line to this line, because you might say 3 to the power something is equaling 3 to the power something. So those somethings must be the same. You might say that, or you might do some loggy stuff. I think either method there would be fine. So, we're down to this point. That's where we're up to. Now I need to solve it because I need the possible values of x. So, the question is, does it factorise Oh, I don't know. Normally at this point, somebody would shout out the brackets. Minus... Oh no, I'm under pressure. This is a disaster. Minus 3 and plus 5? 3x squared minus 9x plus minus... Right. Sorry, that took a very long time. Right, I factorised it. Use a method to factorise or look like an idiot on a video. Up to you. And then solve it. As so that they are your two answers for question 12. Right, I'm going to stop this video here. I'm just worried if I go on for too long, the files are going to be too big for me to deal with. So I'm going to stop there, and then I'm going to finish this off for questions 13, 14 and 15 in one last video.